Hi, Kat here for Lightwave Digital. In today's video, we're going to talk about the ability to set something like a logo or a texture on fire using TFD and a concept called fuel masks. While this may seem slightly more advanced than a regular TFD video, this is actually a very straightforward effect to achieve. So let's get started on that. We're going to close the scene out. We're going to start from scratch. Okay, let's get our emitters and our containers set up. All right, so let's load our oil ground fire plane. Okay, let's go to the perspective view and check that out. And this is about 10 meters by 10 meters on the X and Z. Let's go and load our fireball. Okay, so now we've got a ball in the scene, and we need some animation on this ball to get it to roll across the logo to help it touch off the fuel that's being emitted by this eventually. So let's do that now. We're going to do that with bullet. Okay, so we're going to go to the item properties for bullet, and we're going to add, selected from layout, there's our fireball emitter. We're going to use this as a rigid object, but we're going to set it to sphere, and its collision margin is fine. It can sit there. One thing I'm going to do here before I set this up completely is we're going to give the plane a little bit of a Y offset in the positive direction, and that will seem a little bit silly right now, but it's actually for a very good purpose. The idea being here is that we need a little bit of offset so that it can sit inside of the container once we set it up. So it'll just be hovering a little bit off the ground or off the ground plane. Okay, now that we have that done, let's select it and make sure that it's in bullet as a static mesh, and we'll just use box so that bullet is taking care of the mesh calculation rather than the mesh contributing to bullet's calculation, and it'll go that much faster. So we need to select the ball again, and we're going to give this a little bit of animation so that kind of bounces and rolls in. Okay, so 10 frames is all we need. So we'll set it off to 10 frames. We'll give it a little bit of a push into the scene. Turn the dynamics off for a second. Okay, then we'll turn the dynamics back on. So now we've got something that kind of bounces and rolls into the logo, and hopefully that'll set things on fire a little bit more quickly. So that works. All right, let's get the container going. Right now there's no container in the scene, so we need to add one. So let's go back to TFD containers, add container, give this a name, convol or container volume for short. And as you can see, it's built one right directly in the center of the scene. It is only 1 meter by 1 meter cubed, and it's sitting directly in the center. So let's get this to 10 meters by 10 meters by 10 meters and offset it. Now you can do this offset in one of two ways. You can offset it directly in layout by adding 5 meters to its y-axis, and it'll be sitting directly there. Or you can offset it here in the grid offset of 5 meters, and it'll basically end up in the same place, but without a keyframe added to it for that offset. So whichever way you do this is up to you. I prefer to leave it as so. And unlike some other programs that are out there, you can put a TFD container pretty much anywhere in the scene. You can put multiple containers in the scene, should you choose. Let's change the cache directory location. For this, as I've recommended in other videos and in the quick start guide for Turbulence FD on the lightwave3d.com website, this should be located on a very fast SSD at least, or an M.2 drive. All right, now I've got a little bit of simulation here from a previous test, so it's turned itself blue there for a second, just to show what the simulation data was there before. We're going to change this in a second though. So temperature by default is always active. We're going to need density as well. And we're going to go over to the solver and smooth collision surfaces just to make it a little bit smoother. And we're going to make sure that we have cache density, cache temperature both activated. Cache velocity for this demonstration is not necessary, but in most visual effects setups, if you want to work with motion blur and velocity displacement, yes, it's going to be required, but we won't need it for now. All right, so the voxel size here is set to 20 by default. We're going to set it to 25 because we don't need that kind of resolution here. And now let's talk really quickly about emitters. Let's set these two emitters up. We'll start with the ball first. We're going to make this an emitter. Okay, so we're going to give this a texture volume scale of 0.5 just to have a little bit of animation breakup on it. And we're going to go single object. We're making a collision object, and we'll make it 20 millimeters for the radius. That'll give a guaranteed interaction between each voxel as it travels across the screen. Okay, so we've got all that going there. Let's give it a little bit of pressure, just so it's got like flames kicking off of it. And we're going to set the temperature to 1 and the density to 1. All right, so let's go to the ground plane. Okay, we're going to make this a collision, at least, just for now. So we don't need it to be children. We're going to cause this to be 25 millimeters. And just really quickly, we're going to simulate this just to see what we're getting. So we've got fluid coming off of the sphere. And right now it's just using the default fluid shader. So it's going to be blue. But we at least know that our ball works and it's kicking off some type of gas. Okay, so let's change that so we can actually see what's going on. So here's the viewport. I'm going to go and change the channel shader to temperature. All right. And now we can get into the fun part of the simulation where we need this ground plane to emit off of its texture. Now, the way to do that, to set it up in channels, is we're going to give it a little bit of fuel. Not too much, but just a little bit. So we'll go 0.5, and we're going to give the burn 0.35. Okay. And over on the texture side, we're going to make sure that this only emits from the logo itself. To do that, you need a UV map or something that's very simple in terms of an image plane that can be picked up by TFD very easily. I'd recommend using UV maps. So we're going to go and select a UV map. We're going to go and say it's oil fire UV, and we're going to make sure that it's the Lightwave logo 4K. And the reason why it's 4K is just to make sure that it's high enough resolution so that it accurately picks up off of what is a value between 0 and 255 white. Now this was originally blue. I went into Krita to paint some of that stuff out and just use a quick fast fill. So it's a little bit chunky, but it's okay. It'll work just fine. Now, while this image is black and white effectively, we need to tell TFD that we only want the white portion to kick off data. So we're going to have to add another layer in here. So we're going to go to a procedural. We're going to drag it underneath, and we're going to change this procedural to value. And we're going to set that value to 0. So that black is black, and anything above that value, even if it's just here as white, it's going to make sure that it's just kicking off the values with luminosity present, whether that's from 0 to 255, it doesn't matter. Okay, so that sets that part up. Okay, so we've got our fuel mode, our burn mode. Okay, so let's go over to fuel. We're going to activate fuel. We're going to select temperature as the thing that sets it off. And we're going to set the expansion for this up to something really high, like 4. And for the temperature emission, we're going to go 0.5, the density emission 0.5. So temperature effectively is going to be our fire shader, and our density is going to be our smoke shader. And for the burn, we're going to turn burn active, and the decay mode, just leave this to defaults. And we should be able to hit start. But before we do anything, let's make sure we save this. Okay, and we should be able to hit calculate without any issue. So let's do that now. Just move some of this stuff away. And we'll notice here that once the ball hits the ground, the flame will now catch fire of the fuel that's being emitted by that logo. And the burn control essentially determines how fast it's going to burn with that expansion value in the fuel. Now to speed this up a bit, I can turn the update off, and that will reduce the amount of overhead that layout and TFD are working with, because it doesn't have to redraw the scene every time. And you can see that we get an immediate speed boost. Now I probably need more frames here to get the full logo on fire. If I was working with velocity caching, I would be able to continue without having to start from zero again and get it to just pick up where it left off, because it knows the direction of the voxel expansions in the contact inside of the voxel space, and it can just pick up off without having to redo the whole thing. But you can see here that this ball, once it rolls across, it follows the shape, the flame follows the shape of the logo, and away you go. Now for shading this, let's go over to the rendering tab. Let's go over to mapping for density. Turn that mapping on. That should be fine. Probably pull this down a little bit, just so it's not smoky right off the start. And we'll do an illumination of like 50%, maybe some multi-scattering, nothing crazy. Reduce the fall off to like 30%, and pretty much leave it at that. Oh, maybe 2. There we go. Let's go talk about this fire shader. Now, a lot of people look at the fire shader in TFD and go, well, this isn't really what I want. It's very canary yellow. It's not looking so great. And granted, there is a reasonable understanding of why people get that impression, but it's very easy to control. We're going to add a little bit of dampening to this, and the white point is going to get changed. And we're going to change this so that it's a tighter curve. And this is the beauty of TFD's OpenGL functionalities. We can get this wonderful redraw in real time that looks great, and with the exception of some of the subgrid detail and other texturing functions of it, it gives you a really good approximation of how this fire is going to look. So I think we'll work with something like that. Maybe pull this in a little bit, give it another spike. Okay, so for subgrid detail over on this, fire noise intensity, let's go 0.25. We'll leave it there, and then we'll go 0.25 or 0.5, which is going to give it a little bit of flame lick. And just really quickly, I'm going to turn the mapping of the smoke off just for the moment, because there's also one other thing that I need to do there. And we're going to turn VPR on so we can see what this fire looks like just like on its own. Now, there's no fire. Why is that? Well, the reason for this is because TFD is technically a legacy volumetric effect at this time. And by default, Lightwave, when you first start it up, it's going to work in its new volumetric system. So we need to change this. So over in the render properties, you can hit Control P to also access this tab. You need to go to the volumetric tab and just turn on use legacy volumetrics. And now we have our fire. Okay, so let's play around a little bit with these fire noise settings. Let's go 50 millimeters on that. And we'll go 1 meter on that. Just give it a little bit more chew. Yeah, that feels a little bit better. And I think that's probably okay. Let's change the opacity mapping down to like 0.8, so we can see a little bit better through it. And we can take some of that bright canary off by just reducing the red. So let's go 70% on the red. Okay, that gives it a little bit more of a wood burned tone. Maybe we can go 105 for the green, and 90 for the blue. That's a little bit better. Okay, now let's talk about smoke. Smoke, because it is something that can be impacted by lighting conditions, is something that you want to do very carefully with VPR being open, because anytime that you do something, it's going to refresh it, and if you have subsurface or multiple scattering enabled, it's going to do a big calculation step each time. For now, what we're going to do is we're going to just turn off the multiple scattering. We're going to go back, turn the mapping on. Okay, and we can see that it's kind of colorized it in a dark gray way. For right now, and this is apparently getting fixed in the next build, we're going to go over to the color opacity shader, and we're going to disable this gradient, because this is not actually working in this current build, but it will be shortly. So we're going to just disable it completely, not by just unchecking this. We have to turn it right off completely. So to do that, Shift T, there we go. And we can now change this to a very, very dark color. Let's set it down to like 10 for value. So it's a very dark black, not totally black, but quite dark. And now we've got some smoke in there. I'm going to add some subgrid detail amount to this. Let's go something very similar to what we had with the flame itself, but a little bit larger. And we want to make sure that our smallest smoke size is the same size or lower than our container voxel size. So that's 25, and we're going to go well, let's go 300 for that. Okay. You can see that it's a little bit slow, but we like what it's doing here. This isn't bad. Now we need to basically turn VPR off. Okay. And we can go to the viewport preview. We can change the shader. We can go and take a look at just the smoke. Okay. Um, this is going to just give you a very simple shaded version of that smoke. It's not going to have a lot of information to display in there to give you an idea of what's going on, but it's there for when you need it. Let's go back to rendering. Let's turn on the illumination. Let's turn on that multiple scattering, and let's hit F9. So 2 passes to the multi-scattering step. And because my camera is actually off on the side, but this is good because now we can see what it's doing. You can see that we've got smoke on there as well. All right, let's go and change our camera to something a little bit more interesting. Hit Shift C to select the camera. Get rid of this set of windows here that we don't need right now. And put ourselves a little bit closer to something fun. And let's go right down to the end of the simulation and see what we've got here. Now, one of the reasons why the smoke doesn't look super, super awesome is because we have too many lights contributing to it. We really only need, when we have the multiple scattering option enabled, because this is kind of like an artificial global illumination effect with a light. We don't need the container to see the secondary light, which is the environment light. So let's switch to the environment light, and we will actually just turn the container off for being evaluated by Lightwave's renderer and the TFD shader itself, and we can now get something a little bit nicer. So let's increase this noise intensity. Let's go 1 meter there. And oh, that's 300 meters. We don't want 300 meters. We want like 300 millimeters. There we go. So that's going to be a little bit noisier. And now you've got a smoky, fiery logo. Very cool stuff. Let's set our container animation to cover 300 frames instead. And let's hit start on this, and we'll just do a recap of what has been taking place here. We have our oil ground plane, obviously our ground plane for interacting with the bullet, with the fireball emitter. The fireball emitter is the actual ignition source for the fuel, and the burn parameters. And we're shading it with just simply the temperature being the fire shader and density being our smoke shader. And again, if we turn the update off, you'll see a very, very considerable increase in how fast this is going. And you'll note that I'm using the NVIDIA GeForce RTX 460 Ti, and my system processor is a 16-core AMD Ryzen 9 7950X, so it's 16 cores, 32 threads, which is a pretty decent computer these days. Nothing too crazy. And I'm told that in future builds of this round of Lightwave, we're going to see a speed increase on Turbulence FD for its calculation speed. And hopefully in the near future, i.e. the next build, the problem with that gradient will be also resolved. And further down the road, it will no longer be classified as a legacy volumetric effect. So let's turn our update back on here, see how far that logo is spread. Let's re-update that preview. See how cool it looks. It's looking pretty cool. A couple ways to speed this up is one, we can increase the size of each voxel from like 25 to 30 to even 35, and it will still likely interact very easily and accurately. And that reduces the amount of data being evaluated in the container, and of course the amount of disk space that is being consumed and how large the frames of voxel data are being written to disk. Okay, another 25 frames to go. And once this finishes, there's something I want to explain regarding the settings that I chose for the fuel and burn mode and why they're offset. Okay. All right, so that's 300 frames simulated now. Okay, we can scrub through this very, very quickly. Again, it's that lovely M.2 drive that I've cached this scene to. And now that we've got something here, let's explain what is going on with this fuel and burn mode. Fuel is the amount of fuel fluid that's being emitted off of this white surface that we've told the object is the emission area. Burn is how fast it's going to consume that fuel, or in how many units it's going to consume that fuel. If we set this to even, more or less, so like 0.5, it would consume the fuel as fast as it was being produced, and you would get the shape lighting up, but it would immediately burn out almost immediately after. So you would have the shape of the logo drawn out, but the fire would go out almost as fast as it would follow the shape. So by using a slightly lower value or a consistently lower value, it will kick off fuel and then burn through that fuel. But because we're keeping the fuel rate at a constant value above the burn value, it's always going to continuously have fuel to burn. If we wanted to, we could take this and put an envelope on it and say after 150 frames, turn this fuel emission value down to 0, the burn value would eventually catch up with the amount of fuel produced and consume all of it. So, very, very simple concept. Let's take a real quick gander at what this looks like. I'm going to back the camera off a little bit. So Shift C again to camera, or select the camera. Yep. Okay. And we'll hit F9. Goes to the first pass in the multi-scattering. Typically, the first pass is going to be the slowest because it's the better evaluation of the two. And then the second is an interpolation of that. Almost there for the first pass. We'll see just how much faster the second pass goes. Poof. All right. Now it is a little dark in here. Again, we did turn off the environment light, but this can be supplemented by having another light similar to a distant light, just kick in from a different angle, or we can use the ambient light feature, or we can change the parameters of the container rendering so that it has more illumination, more scattering, so that the fall off can transfer all the way through it. This can also be a factor of the thickness. There are a number of different values in here that all contribute to that look. So anyway, that is the conclusion of this video. If you have any questions, you can always get a hold of us. And make sure you read the quick start guide at lightwave3d.com for Turbulence FD. Once again, I'm Kat. Thank you very much.